Yeah. So this is the how to fire. This is the impact of the firewalls on the network. And we have wireless devices. In today's life, wireless device is very much important. Okay. And if you are speaking about the wireless devices, first we can say about the access point. As I told you, all the access points comes under the network access layer devices, which are deployed at the access layer of the network. Okay. We have a variety of options like indoor, outdoor, managed, and unmanaged. Indoor is very simple. The device is latency sensitive. It can be deployed inside the building or inside the home. Outdoor is you can deploy outside the home. For suppose think that for two buildings, I have a I have an office which is having two buildings, and for these two buildings, I need to deploy only one access point. Ultimately, I need to deploy this outdoor one. Why? Because if I use indoor one, it can only give service to this building. And what about this building at the top? So it will be the water resistant or water resistant, sun resistant. Everything. It will be a little a good one. And managed one is which has to be managed. Okay, that in the sense which has to be monitored, where this monitoring can be done locally or the cloud based. You can do either of the ways. And unmanaged, once you deploy it and if you leave it, it goes on. It's like it has to be maintained every periodically it has to be maintained and it has to be checked whether it is working fine or not, whether everything is good or not. Management has to be done in periodical cycles. And that management again it can be done locally. If it is deployed in my home, I can locally do it, or it's cloud. Through the cloud it can be monitored. It is either of the ways you can do it. Okay. And the other is unmanaged. There is no need of once you deployed and you left it, it keeps on. And yeah, we use managed. Okay. And we have Wi-Fi and NICs. Now my laptop can communicate with the ISP. Okay. If I in olden days, if I want to communicate with ISP, I should have one physically wired connection. That is which how the communication happens through the NIC, network interface. But in today's technology, we use Wi-Fi NICs, which are wireless NICs. Okay, whatever the signal is received to these NICs from my PC, it will convert them into radio waves and send. So these Wi-Fi NICs are the very most important things for the access. And even these devices have the Wi-Fi NICs. Then only they can be able to communicate. Wi-Fi NICs are very similar to these NICs, but these are physical, and the Wi-Fi NICs are logical. They can be logical or physical, but whatever again the working will be the same. But here these NICs they are converting the signals ones and zeros bits into electrical signals. But Wi-Fi NICs they will convert them into radio waves. That is a different. That's nothing else. Purpose will be the same. And yeah, controllers. Controllers are the devices. Okay, controllers are the devices which are used to monitor or maintain the access points. Okay, if you are having around 30 to 50 access points, instead of going to every access point and instead of configuring directly to the every access point, you can do it from one centralized device, that is controller. Okay, you can manage them, you can troubleshoot them, you can maintain them, you can configure them. All this can be done through only one centralized device, that is control. And again, these are we have various of options where according to the options the uh, number of access points is dependent. If you are having less number of access points, you'll be using one model, and if you are having high number of access points, you'll be using one model. Okay, if you want to go in depth, that is not our cup of tea. You can study wireless if you want to do all this. If you want to know about wireless devices, we need to do the wireless certificate. Okay, but here for our CCNA, we can discuss about these controllers are standalone, modularized, and can control different maximum quantities of APIs. Okay, these standalone and modularized are the options which are available in the market now. Standalone are devices which have switching engine in them itself. In the sense, the device will itself have the processor. Okay, and modularized is you will be having a separate processor, a big processor, and you will be having the modules where you can insert many controllers to it like this. Okay, it is very simple. It's like a rack. You will be having the processor to it, a big processor to it, and to that processor you can attach how many number of access points you want. You can keep on adding, and that processor will be dividing its work based on the number of access points you attached. That is a modularized one. And standalone, it will be used for a small number of access points. And if you are having maximum number of access points, then you will go for modularized. Okay. So depending on the model, different maximum number of quantities of APs can be configured or maintained. So this is the image of the yeah. How do Wi-Fi components impact the network? First thing, cost will be reduced. Why? Why? Because if you are using wired connection, you need to maintain a switch, and to that switch, you need to give the wired connection from your PC to the switch. The cost of cabling will be reduced using Wi-Fi or wireless access. First point. Second point is today's many devices don't even support wired LAN connections. Today's technology has become this. If you're considering your mobile, will it support the wired connection? No, wireless. That is a thing. And third thing is, if you are using wireless connection, you can go everywhere in the home. In the range of the signal, you can go everywhere and you can see wherever you want comfortably. But if you are using wired, you cannot. You have to sit in that one position and you need to configure or you need to communicate whatever the thing you want. Yeah. Then this can become overloaded with traffic causing latency or even the inability to connect the network. Do you want to speak? Yes. Yeah, you can. Okay. So, but if you're using these wireless devices, mm, these causes a latency and even the inability to connect the network. If the device is overloaded, okay, traffic is more on the access point. You can even not able to connect to the device. The new devices, whichever want to connect, they cannot connect. With this third point, this point, it's very simple. See, I have an access point now. Actually, its capacity is it can per second, suppose think per second, it can process some thousand packets. Okay, it can process thousand packets. But my whatever the devices are connected, they are generating many more packets than its capacity. For suppose per second, now it has to process some 10,000 packets. Okay, now what it does is whatever the new connection, whatever the new device want to connect to it, it will not allow. First thing, you cannot connect, and the device becomes slow. This is the drawback. This what is this? Can become overloaded with the traffic causing latency, slow, or even the inability to connect to the network. Okay. And see the typically recommend to pair with security, which can bring its own problems. Can make troubleshooting more difficult. If you're not using security, again the same problem as I told you. If you're not using firewall or the security is if you don't pair it with security, this can be its own problem, and troubleshooting will be difficult for the access points, wireless access. Troubleshooting will be different. See, if you are having the wireless, see if you are having wired, you can just see if you are not able to connect, you can troubleshoot it easily. First, you will replace a NIC, or if you replace a cable with another cable, and you will think according to the level OSI level, and you will troubleshoot it. But if you are using wireless, they are not connected physically. How do you know where the packet is going on? The troubleshooting will be. So these are the devices, and this is all about the introduction of the networking and how does the communication happening, how the Cisco three-layer architecture works, the design they are recommended by the Cisco. These are all the things. Now let's start the networking, that is OSI model.